Welcome back, everyone. We've torn mobile devices apart and we've looked at their external accessories. Now, it's time for CompTIA A Plus Core 1, Objective 1.3, Configuring Mobile Network Connectivity and Application Support. Today, we are learning how to build and provision the modern mobile device from the ground up. To understand why this matters, we have to look at the field tech dilemma. On the left, we have the isolated device. If a device has no signal, your tech cannot access corporate data, cannot communicate, and cannot submit field reports. But on the right, we have the unmanaged device. If we just give them a completely open phone, we are prone to data leaks, excessive cellular roaming charges, and massive security breaches. Our IT mission is clear. We must provision a device that balances seamless connectivity with absolute corporate security. To achieve this, we are going to build this device using the 4 layers of mobile provisioning. Layer 1 is local connections, which covers Bluetooth and Wi-Fi. Layer 2 is global connections, covering cellular, hotspots, and location tracking. Layer 3 is the corporate shield, where we deploy MDM, MAM, and BYOD policies. Layer 4 is the data flow, focusing on synchronization, apps, and data caps. Here is a major exam tip for you. Objective 1.3 tests your knowledge on the exact configuration steps for each of these 4 layers, so pay close attention to the setup processes. We start at layer 1, establishing the local network. Wi-Fi radios can easily be enabled or disabled directly via the OS notification shade or control center. When making an SSID connection, you must carefully manage whether the device is connecting to secure corporate networks versus untrusted public networks. From a hardware perspective, remember that Wi-Fi antennas are typically routed around the edges of the device display to maximize signal strength. Exam tip. As technicians, you must know how to manually configure hidden SSIDs and locate the device MAC address within the advanced network settings. Also in layer 1 is pairing local peripherals using the Bluetooth standard, which supports short-range personal area networks, or PANs, for headsets, scanners, and input devices. The process is always 4 steps. Enable. Turn on the Bluetooth radio on both devices. Discover. Place the peripheral into discoverable mode and locate it on the mobile device's menu. PIN verification, enter or confirm the automatically generated passkey to ensure security. Test, verify the connectivity and actual functionality of the peripheral. Now we level up to layer 2, moving into the field with global connections. Cellular data, whether 3G, 4G, or 5G, connects the device to the internet via a cellular provider's radio towers. Your data rates and speeds will depend heavily on both the device's hardware capabilities and the local tower technology. For cost control, you must know that cellular data can be toggled off individually. This is crucial to prevent expensive international roaming charges or data overages while leaving the Wi-Fi radio active. To access those cellular networks, we need subscriber identity. The traditional method is the physical SIM, or subscriber identity module, which is a removable card that identifies the device to the cellular network. The modern method is the eSIM, or embedded SIM, which is a digital profile stored directly on the device hardware. Because of these dual capabilities, modern devices allow multiple eSIM profiles to coexist. This allows a field tech to maintain both personal and corporate phone numbers or data plans on a single device, or easily change them on the fly. Sometimes your field tech needs to act as a router, which brings us to tethering and hotspots. This is the act of sharing the mobile device's cellular data connection with a secondary device, like a laptop. You can use USB for a direct wired connection that charges the device while sharing data. You can use a Wi-Fi hotspot to broadcast a local SSID for multiple devices to join. Or you can use Bluetooth for lower bandwidth sharing, which is highly useful for battery conservation. The last part of layer 2 is tracking and privacy. Mobile devices use location services to determine their physical location using a combination of global positioning system, or GPS satellites, cellular tower triangulation, and local Wi-Fi networks. They also use an internal sensor called a magnetometer to provide accurate compass directions. However, we must manage privacy controls. Technicians must configure app-level access. strictly balancing the company's need for corporate tracking with the user's privacy requirements. Moving to layer 3, we face the ownership dilemma. Does the company buy the phone or does the user? Corporate-owned devices mean the enterprise buys, configures, and fully restricts the hardware. It offers total control, but at a higher cost. Conversely, BYOD, bring your own device, means employees use their personal hardware for corporate access. This yields high user satisfaction, but requires incredibly complex security boundaries. The solution to manage both is Enterprise Mobility Management, or EMM software. If we are dealing with corporate-owned assets, we use MDM, Mobile Device Management. This is software that enforces security policies at the absolute device level. Key capabilities of MDM include enforcing strong PINs and biometrics, executing remote wipes for lost or stolen hardware, and even disabling physical hardware features like cameras or microphones in secure environments. But what if it's a BYOD phone? We can't wipe their family photos. That's where MAM comes in. Mobile Application Management. MAM sets policies for specific corporate apps without controlling the entire physical device. It uses containerization to create an isolated, secure enterprise workspace right on a personal phone. Crucially, it supports data loss prevention, or DLP, which prevents a user from copying confidential data from their corporate email app and pasting it into their personal social media app. Finally, we reach layer 4, the flow of information. Mobile synchronization is the process of ensuring data remains cohesive and up to date across all user devices. Your primary sync data includes calendars and appointments, contacts and address books, and mail and messages. Note the modern shift here. Manual syncing via physical cables to PCs has been largely replaced by continuous, over-the-air cloud synchronization. A huge part of that sync data is corporate communication via business applications. Keeping corporate apps, mail, and cloud storage synchronized securely is paramount. You must know your email configuration requirements. IMAP uses port 993 for retrieving and syncing mail across multiple devices. POP3 uses port 995 for downloading mail to a single local device. SMTP uses port 465 or 587 for sending outbound mail. Exam. Tip. Be absolutely prepared to manually enter these exact server addresses and secure ports if auto-discovery fails during setup. The last hurdle in Layer 4 is managing data constraints. Cellular providers place strict limits on data consumption called data caps. This leads to the danger of sync. Automated background synchronization of cloud storage or massive email attachments can rapidly consume a user's data limits. The solution is that technicians must explicitly configure sync policies to restrict heavy data transfers, like OS updates or large file syncs, to Wi-Fi networks only. And there we have it, the fully provisioned device. Let's check our device setup tracker. Layer 1 local. Wi-Fi is secured and Bluetooth peripherals are paired. Layer 2, global, cellular is managed, hotspots are ready, and location tracking is correctly configured. Layer 3, shield, MDM boundaries are set or BYOD apps are containerized. Layer 4, data, business apps are synced, and data caps are protected. Status, the technician is fully deployed. You are now ready to crush CompTIA A+ Objective 1.3. Thanks for your focus today.